Hey guys, welcome back. Well, today we're looking at this frame. I think you know it. It's the WalleFPV Eagle 2. And there's been a lot of videos lately on the bind and fly version. But here, we're going to take a quick look at the frame. We'll do a quick frame overview, and then I'm going to fit out the frame. So I'm going to fit it out for freestyle. Now, the original bind and fly comes with 1002 size motors at 14,000 kV, and they're running it on a 3S battery. And this might be great for cruising, but this is not the best setup for freestyle. So I'm going to show you my process of choosing the correct motors, batteries, and props for freestyle. We'll fit it out and we'll give it a fly. Let's get started. Okay, so first of all, the frame overview. And let's start at the very beginning. And first of all, I purchased this frame through WalleFPV website. And I purchased it with my own money, so of course WalleFPV has had no input into the making of this video. So this has actually been sent in a box. Now, just in case you're interested, this frame was originally designed by YMZ-FPV, which are now closing down. And as I believe one of the staff members, Wally, has taken the project over onto his own website and is now producing and selling this frame on his website. And the first thing I'll notice is when you open the box, it actually comes pre-assembled. So many kits these days just come as parts and you have to build them up. And of course you have to take the kit, you have to take the frame apart anyway to fit it out, but at least having it pre-assembled, you can see where everything goes. Even the antennas and the antenna for the receiver is all installed there ready to go. So that's a good point. Now, as well as the frame, you get a couple of little extras in the box. So we'll take a look at those. 2 screwdrivers. This one here is a hex screwdriver and this is a Phillips head screwdriver. You get some extra bolts. These are M2 bolts, so we've got 2mm, 3mm, and 4mm bolts, as well as the bolts that are already in the frame. And if we have a look at these bolts that are on the base plate here, these are for the flight controller mount, and these are 13.35mm, so they're 12mm bolts. Okay, as well as that, you've got your standard antenna mount here for whip antennas. And this one here, this is actually for 04 setups with the dual antennas. So that comes with it as well. And then you've got your battery mounts. Now, this is important. These battery mounts are actually exactly the same size. And the reason for that is that you can choose to put one in the middle of the frame, or you can put them front and back. And that's why they come being the same size. But if we measure the size of these, and if you're going to do a fit out, this is quite important. The internal height is 15mm and the width is 18mm. Now, I've actually got a battery here. This is a 350 mAh 3S battery, GMB one. And if I try to put this in here, it actually won't go in there. No matter how hard I try and put it in there, it won't go in there. So if you're going to build this frame out, and if you're going to use the 3S battery, best just to measure your battery and check the size, make sure it fits. So let's put these battery mounts on front and back and we'll see how that looks. Okay, and there we go. So if you see, you can see they stick up a little bit. And this sort of seems like they're just not quite wide enough. Maybe just a fraction wider would have been better in that in this gap here. Maybe when you put the battery in, if you put the battery in and we pull this out a bit, they might sort of sit down a little bit better. Okay, but that's how they fit. Let's try putting them in the center position and see how that looks. Right, so there's the battery mount in the center position. And if I hold it like this, you can see how much that sort of sticks up there. Now, once again, when you put the battery in, that might sit down a little bit. But I just think you're going to have to lift the flight controller up just a little bit higher just to clear that TPU that could be sticking up there a little bit. Now, this frame is designed to have the VTX mounted on this top plate here. For example, in the bind and fly version, you've got the DJI 04 Pro mounted there on the top. But if you've just got a single board VTX like a HD0 or Walk Snail or even 04 Lite, you could actually mount that above the flight controller. Now, these bolts here are 12mm, so to do that, you're going to need 22mm bolts. So let's take a look at the height in the frame and see what clearances we've got. So if we look at the spacing inside the frame, so we've got exactly 24mm, and that's from the base plate to that top plate there. Now, if you are looking at actually mounting everything on the stack, I wouldn't advise removing this top piece here, this top plate here, because this is actually structural. It's actually made of metal, and that screws at 4 points into the frame here, and actually gives a lot of strength. So 24 millimeters is what you've got to work with. But just remember, you've got these things sticking up a couple of millimeters too, so you're going to have to lift your flight controller up just a little bit. And while we're here, just in case you're wondering, you've got about 13 millimeters of spacing between that camera mount screw and the front of the frame there. And something you might notice about this frame is the carbon doesn't actually have the twill pattern on it. Okay, it doesn't mean it's not carbon. This is actually a carbon frame. And that twill pattern is actually just a coating that's put on the top of most frames anyway to give it a nice look. Okay, so it's just the plain bare carbon. And that's what it looks like. So while we've got the calipers out, let's just measure the camera cage at the front here. So the internal spacing is, let's say it's 20 millimeters. And this is actually hard compound rubber here. Okay, so that's going to give a little bit of really good dampening for the camera. Right here, what about props? Now this is, this runs 1.6 inch props on the Ride and Fly version. So I guess a lot of people are probably thinking, could I actually squeeze it and just run 1.7 inch props, which are 45 millimeters? So let's put some motors on there and see if we can swing a 1.77 inch prop, a 45 millimeter prop. Okay, so let's see if we can spin the 1.7 inch props on this frame. And unfortunately, it's actually not going to work. These 1.77 millimeter props, 45 millimeter props, you can see us touching the frame on the front there, and on the back, you can hear it rubbing on the frame there too. So unfortunately, with this frame, you're going to be limited to 1.4 or 1.6 inch props. Now for this frame, you're probably going to want 1002 or 1003 size motors. Now most frames that take those size motors, like this one here, will have a base plate that's about 1.5 millimeters thick. However, on the Eagle 2, the base plate is 2.25 millimeters thick. So the screws that you get with those 1002 size motors are actually not going to be long enough. And you're going to need a screw like this. This is an M1.4 by 4 millimeter screw. So you can see the overall size is 4.66 millimeters. So that's 0.66 millimeters for the head and basically 4 millimeters for the screw shaft. Okay, let's put this on. We'll see how far it sticks out. Okay, so you can see there, that's the amount of screw that you get coming out the top. And that's about what you'll need for a 1002 size motor. So remember, 1.4 and 1.4 by 4 millimeter screws is what you're going to need. And one more thing I want to point out before we go on is at the top here, you've actually got a receiver mount. So you've got a dedicated place to put your receiver. And it's very different to a lot of other builds that we do with micros where you don't know where to put the receiver and you end up, just gluing it to the back of the camera or something like that. But on this frame, you've actually got a dedicated place to put the receiver. And it's really good to see that they've done that. And then, of course, your antenna just goes around there and clips on. So that's a great feature. Okay, so before I forget, let's weigh the frame as it comes out of the box and see what weight it comes in at. And the all-up weight is about 18.2 grams. Right, so let's take the frame apart and see all the individual parts. And something that really impresses me is the quality of the machining of this frame. I mean, this is not a cheap frame. This frame will cost you every bit as much as a 2.5 or 3.5 inch frame, and it's a lot smaller. Now, I think this part here is probably a good example. So this is not just a flat sheet of alloy that's been folded. You can see this is actually being machined out. You can see this block here is actually being left in, and it's also being tapped with a thread here as well, top and bottom. So these are actually machined parts, not just folded aluminium parts. And another example here, a little bit harder to see, but this piece here, this black piece, it's actually got a machining hole there. So these need to be put in a special jig to actually do these tapping of the screws into the alloy there. So there's a lot of work that actually goes into this frame to make a frame of this quality. So while we've got it apart, we can have a look at the VTX mount as well. And you can see this VTX mount has actually got 20 by 20 as well as 25.5 by 25.5 mount. So if you're mounting your VTX on the top, then you can use that. Okay, so let's think about the setup for this quad. And I can tell you, I'm sure as hell not going to be using the same setup as they're using on the Bind and Fly. You see, on the Bind and Fly, they're using the RCM Power 1002 14,000 kV motors with 1.6-inch props and a 3S battery. But that motor is not designed for 3S. It's designed for 1 to 2S. So what they're doing is they're using an 80% throttle limit in Betaflight. Now, an 80% throttle limit, actually, it does the same thing as reducing the top speed of your motor. So instead of 14,000 kV, it's going to be less. And I don't think this is the right way to go about doing it. In fact, I've been watching some videos on YouTube, and on one video in particular from Nick Burns, he actually smoked a motor. Now, fair enough, he was doing turtle mode at the time, so you can't really say that's the fault of the quad if you're doing turtle mode, but it's a bit of an indicator, I think. Now, this all revolves around tip speed, and forgive me if I get a bit dry here, and skip ahead if you want to, but I'm going to show you a resource on my website, and I use this resource myself when I'm designing a new quad, when I'm deciding what motor, battery, and prop combination I'm going to use, and it's all about getting the correct tip speed. So we'll have a look at this, and we'll see how it relates to the Bind and Fly version of this quad, and then we're going to use it to decide the best setup for a freestyle version of this quad. Let's have a look. Now, on the resources section of my website, if you go to the reference area, and we've got this tip speed calculator guide here. It shows you how to calculate tip speed. There's also a calculator there if you want to do it automatically. And then there's a little bit of data and some examples here of different tip speeds of different sorts of quads. Down the bottom here, there's an Excel file you can download, and that's the one I'm going to be using now because I'm going to change the data and we're going to see how it adjusts the graphs. So the way this form works is like this. Down the left-hand side here, we've got all different sorts of drone categories in all prop sizes, cinematic, freestyle, long range. And this is the theoretical tip speed. Now, in this form, we're not actually interested in actual tip speed. And the actual tip speed is going to be a lot less because, of course, you have to factor in things like the inflow of the air and the number of props and the drag and all this sort of stuff. But we don't need to calculate actual tip speed because we're just wanting to compare one drone to another. And for that, we can just use theoretical tip speed. That's fine. So here we've got things like prop diameter, motor kV, throttle scaling, how many cells, like a 2S or 3S battery. And this is a conversion to change it to miles per hour. And here's your tip speed here. For example, this one's got a throttle scale of 80%, giving us 640 miles an hour for our tip speed. If we change this to 1, which is no throttle scaling, it comes up to 800. So that's the way this form works. Now you might be wondering why I've got these specific values for motor kV here. And these are averages. So the way I get these averages is this. Let's just choose one, 3-inch freestyle. So I've got the motor kV listed as an average of 4,500. So this data actually comes from my FPV motor size sample data. If we go down to 3-inch freestyle and we have a look at that. So you can see here for 4S, this is the motor kV across the side here. And if we have a look at the average, they're kind of grouped around here. And if I average that out and come across here, we get 4,500. So this is my best estimate of the average motor kV for each of these drone types. So the way you can use this form is like this. Just say you're doing a 3.5-inch freestyle build. Now I've got data here for a 4S, and it should be in the high 600s, your tip speed. So just imagine, let's put this in 3.5-inch. Okay, just imagine you had like a 2,200 kV motor and you've got some lying around, but you're going to go for 6S. You're going to run it on 6S. So you can see here, compared to the high 600s, you're sitting a bit low at 550. So if you went up to 2,750 kV, there we go. You're more in the ballpark there. So you can use this to gauge whether your tip speed is going to be correct with the setup that you're thinking of doing. Now I've put all this data into these graphs down here. And if we look at the graph that contains all of the data, we can see it's totally all over the place. There's no consistency here at all. But what we're actually doing here is we're mixing in freestyle and cinematic and long range all together. If we refine it down a little bit and we just have a look at the freestyle, we can see a little bit more consistency there. We're averaging the high 600s. Now, it doesn't matter if it's a 3.5 inch, a 3.6 inch, 3.5 inch freestyle, or a 5 inch freestyle. This is the average tip speed that we're averaging out at. If we have a look at cinematic, then we can see the tip speed is a little bit less. Whether it's a 2.5 inch or a 3.5 inch cinematic drone, we average about 541 miles per hour. So let's go back and have a look at how this relates to our WalleFPV Eagle 2. So we've got it set up here. It's a 1.6 inch prop, 14,000 kV motor. They've got an 80% throttle scaling on 3S. Okay, and we're sitting at 640. So let's go down and have a look at it. It's actually in the graph here for the freestyles. It's this one right here. Sitting at 640, it's a little bit below the average, but it's fine. It's in the ballpark. If we go up and we change that, if we take the throttle limit off, we're sitting at 800. Okay, so now we've got no throttle scaling at all, and we're sitting at a tip speed of 800. If we have a look at that, it's quite high there. Okay, so it's probably best that they do have that 80% throttle limit in there. And you know what? There's nothing wrong with throttle scaling. If you're doing your own build at home and you've got to use throttle scaling to adjust the tip speed or something, that's fine. But the best thing is to choose the correct motor, battery, and prop combination right up front. So I'm going to show you my best setup for this quad for freestyle. Let's have a look. And for my setup, I'm going to use exactly the same 1.6 inch prop that they're using on the original one. But for the motor, I'm going up to a 15,500 kV motor. So this is the Flywoo Robo 15,500 motor. I don't have a throttle scaling on it, but this motor is rated for 2S, so I'm going to go for 2S here. It's going to give me a tip speed, a theoretical tip speed of 590. So if we go down and have a look at the graph, here's my proposed setup here. So you can see I'm sitting a little bit low compared to the average of high 600s, but I'm well within the ballpark, and I'd rather be low than high. So this is the setup that I'm going for. So let's look at the components that we're going to use for the build. I'm going with these 1002 size motors. These are the Robo motors from Flywoo. These are 15,500 kV motors, and you can see they've actually got a piece of fiberboard there with some pads on it that the wires connect to. So that keeps them nice and secure. And that FR4 fiberboard piece, that actually stops the screws from going up into the windings. So it's a really nice design. For the props, I'm just going with these Gemfans 40mm props. They're the 1608 props, and they're the same props that they're using on the Bind and Fly version. I'm going to try and add a beeper on if I can. With those small motors, the D-shot beacon noise is not very loud at all. I'm going to be flying outside, so I'm going to try and add a little beeper on as well. For the receiver, I'm going with this ELRS one, and the width of this receiver is 10mm. So at 10mm is going to fit really nicely into that receiver mount at the top of the frame there. I'm going with digital VTX. This is a dual board design, but I'm just going to mount it directly on top of the flight controller. For the camera, I'm going with this 14mm camera. You can see it's got this rubber piece around the outside there that brings it out to 20mm. Of course, this frame actually fits a 20mm camera, but I'm just going to go with this micro camera. If I put this in here, the camera is going to sit back about here, and you can see it doesn't actually stick out at the front there past the camera cage. So I'm just going to go with that smaller camera. For the battery, I'm going with this one. It's a 2S battery, and it's 450 mAh. So it's got a BT 3.0 connector. I'd really rather go with an XT30, but I don't have any 2S batteries for the XT30, so I'm just going to go with this one. It'll be fine. For the flight controller, I'm just going with this one. This is the Hack RC F4126. This one's got a 35 amp ESC. Now, the Bind and Fly, I think, has a 20 amp ESC, the flight controller there, but to be honest, these days, you're not going to find many flight controllers with a 20 amp ESC, and a 35 or 40 amp ESC, the flight controller is only going to be an extra half a gram anyway, so it really doesn't make any difference. So that's the flight controller I'm going with. Now this is an all-in-one flight controller with a built-in ESC, so let's have a look at the ESC settings I'm using. And of course this flight controller comes with BOLES, so I've updated the firmware to Bluejay. So if we just connect and have a look at the settings, I'll read the settings on the ESCs. Now I've already flashed these to Bluejay, so I've got Bluejay 0.21 on these ESCs. and 48 kilohertz is what I've set it to. For a 1002 on 2S, I try not to go to 96. I always stick at 48 kilohertz. Now, the only other settings I change for my ESC is over here, the minimum and maximum startup power. I increase both of them to the maximum, so sliders all the way to the right. For the motor timing, I changed that to 15 degrees. Demag compensation is set to low, and the RPM power protection I set at 6 times. All these settings down here, I don't change any of these settings. Okay, so that's my setup for a 1002 size motor on 2S. Okay, let's fit the frame out. Alright, it's all done. Let's take a look at it and put it on the scales. Alright, so first of all, at the back here we've got the circular polarized antenna. I didn't want to go with the whip antenna, I wanted to keep the circular polarized antenna. The receiver was a really easy mount up the top there, as was the beeper. So we've got that mounted right up the top there. Around the front we've got the 14mm camera, and if we look at the camera cage, it gives lots of protection there for the camera, going with that smaller camera. Down the back, we've got the battery connector and the capacitor there, just coming straight out the back. Now on the bottom, you can see we've actually got some foam on here. This is 5mm foam, because I'm using the 2S battery. And that foam just acts as a little bit of packing, and the battery just slips in there nice and firmly. Alright, so let's put it on the scale and see how much it weighs. Okay, so first of all, the dry weight is 64 grams. And if we put the 450 mAh 2S battery on, it brings up to about 91.2 grams. So not too bad at all. There we go. Right, so the only thing left to do is chuck it in the air and see if it flies. So I'm just flying down the local park here and just sort of scoping it out and seeing what it's like. We've got some trees here with a high canopy, so that's great. We can do a little bit of stuff in here. There's a playground over there with a tree. Plenty of room. There's that tree. Okay, so I thought I'll just do a backflip through these trees here. Plenty of room. And I was surprised how fast I'm actually coming after this backflip. I'm literally going like an absolute rocket towards the tree. And there it is. Okay, well, let's go back. Well, let's have a look how fast we're actually going out of this backflip. Traveling at incredible speed and straight into the tree there. Well, you know what? I'm certainly glad I put that beeper on the drone, that's for sure. And while I was fishing that drone out of the tree, it got me thinking about disc loading. Now on the drone, we've got 4 motors and the props sweep out an area as they rotate. And disc loading is a function of how the drone's mass is supported on that swept out area. So I wanted to find out exactly what this Eagle 2's disc loading is. And to do that, I'm once again going to take a look at the resource on my website that calculates disc loading. So remember, our weight of this Eagle 2 is 91 grams and our prop diameter is 1.6 inches. So this gives us a disc loading factor of 17.5. So 17.5 is actually quite high for disc loading. So let's just go down, we'll compare it. We'll go past the whoops. We'll go down here to the, here we go, 2S whoops on 1.6 inch props. This is similar to what we're running. And you'll see if we scan the disc loading down here, it's all around 10, 11, 12, 13. The only thing that's higher than our disc loading is these, the newbie drone Acro B and the Flywoo Flylands. Well, I mean, these are not freestyle. These are more like cruisers and cinematics. So of course, you know, for that style of drone, a high disc loading doesn't really matter. For freestyle, it's a lot more important. Let's go down and have a look at some freestyle drones. Okay, so here's some here. We've got different prop sizes from 2 inch all the way up to 5 inch. And if we scan down the disc loading, we can see that the majority of them are hanging around anywhere from 9 to 13. And one that just has stuck out to me is this one here, the GEP RC Domain 3.6. Well, I remember watching reviews when that came out, and people said it was heavy as hell and went like a rocket. And not surprising with a very similar disc loading of 18.6. So I think for really good freestyle, what we should be looking at is something around maybe 9 to 13 for disc loading. And if we have a look up the top here, here's two drones, YMZ-FPV, the Lightning one, and the Dark Knight as well. So these are both 2-inch drones. They're lighter than our drone. They're lighter than this build here. But because they're 2 inches, they've got a very low disc loading. And I think they can be that light because I think from memory, both of these are analog drones. Okay, so this is probably your perfect disc loading for freestyle, but anywhere around 12 or 13 is actually quite good as well. Okay, so with this knowledge about the drone's disc loading, I went out again, and I went to a different park this time, just a small park. And I just wanted to see if I could fly this drone in a small park about this size, where you can see how big this park is. And I just wanted to see if I could fly a drone like this with high disc loading in this park. And you have to remember, when you're flying a drone with high disc loading, basically speed and momentum are your friend. You've got to keep the speed up, you've got to keep the momentum going. For example, you can see if I'm doing some split S's here, I make sure I've got heaps of height, and I'll make sure I've got plenty of upward momentum before I do my roll and the split S. But it's pretty easy flying a drone that's heavy and it's got a high disc loading in this size park. You can do it. It's easy, and you've just got to learn how to fly the drone, and just keep in mind that you've got high disc loading, and just keep that speed up. So eventually I found myself back at my usual flying spot. This park here, it's a larger park. So of course you can fly this drone in a much smaller park, it's fine. But I found myself back here, and I found a lot more comfortable at this park here. I don't know if it's just because this is where I normally fly, or because I have more space. But I just felt that I could keep the speed up a little bit more with a little bit more space. So maybe if you've got a bigger park to fly in, then maybe that's a good idea. What else we got? We've got, oh yeah, flight time is about 3 minutes with the 450 Mark 2S battery. So a good 3 minutes flight doing freestyle. So it's not bad. Now you remember I'm using a 14mm camera, and that camera is sort of recessed back a little bit past the front of the camera cage. And I'm not getting any camera cage in view here. I'm using the Vista system, so I've got the Cadex Nebula Micro, I think it's called, the micro camera. And this is what you're watching here. This is just a goggles recording. Okay, what else do I need to tell you? Oh yeah, spare props. Make sure you take spare props with you. These 1.6-inch props are not made for this weight of drone, so you'll need to have some spare props. Okay, so what do you think about the Eagle 2? Are you going to build one? Till next time, happy flying.